Okay, so this review is meant for my geometry students. We do have a quiz coming up on Tuesday covering sections 6.1 through 6.5. So here I have 12 problems. I know it's a lot of problems, but they're kind of quick going over all 5 sections. So here we go. First problem here. Find the missing angle measure. And we see that x is here missing. We don't know what it is. We count how many sides. 1, 2, 3, 4, 5. This is a 5-sided figure, or a pentagon. So first let's figure out what the sum of them are. We use the Polygon angle sum theorem. We plug our 5 in for our n. 5 minus 2 is 3. And we take 3 times 180. That is the sum of those 5 angles, 540 degrees. So now let's show us adding them together. X plus 115 plus 105 plus 117 plus 100. That needs to add up to 540. We get our trusty calculator and we add them up. 115 plus 105 plus 117 plus 100, and we get that sum of these 4 numbers to be 437. So then we subtract 437 from both sides to get the value of x. And when we subtract that, we get a value of 103. And there's the missing angle measure, 103. Okay, here's problem 2. It says the sum of the interior angles of a polygon with n sides is given. Find n. So this is the sum of the interior angles. So remember, that is n minus 2 times 180. That's how you find the sum of the interior angles. Well, that number is 1980. So again, there's 2 ways to do it. You can distribute the 180, or instead of distributing, you can divide by 180. And that's the path we're going to take here. Divide by 180. N minus 2 comes down. The 180s cancel, and over here I get 11. So then I add 2 to both sides. N equals 13. So n is 13, or this is a 13-sided polygon. Okay, the third problem here, it says, here is the measure of an exterior angle of a regular polygon. Find the interior angle, and then find the number of sides. Alright? Well, recall that if I have a polygon, and I'll just use a triangle, and I have an exterior angle, the interior angle x and the exterior angle y are supplementary. Okay? So if I have the exterior angle is 72, to find the interior angle, I'm going to take 180 minus 72. And the measure of the interior angle of this regular polygon is 108. Okay. So that's that. That's the measure of each interior angle. So now, what is the number of sides? Well, we need to recall that the sum of the exterior angles is always 360. Right? That's always the sum of the exterior angles. And if it's a regular polygon, there are going to be the same number of exterior angles as interior angles. Well, we don't know, so that's n, the number of sides. But we do know what this comes out to be because we are given the measure of each exterior angle. It's 72. So we solve this. Times both sides by n. 360 equals 72n, and then divide by 72. And this will come out to be 5. Find the number of sides. There are 5 sides. And there we go. So remember, interior angles, n minus 2 times 180. Exterior angles always add up to 360. Okay, here's this next one. This one is about those parallel lines, that one theorem from section 6.2. So in this problem it says PQ is equal to QR is equal to RS. So let me find where PQ, QR, and RS is. PQ is here, equal to QR, equal to RS. So what is happening is we have these 4 parallel lines, and they're cutting this transversal into congruent parts. So we know that every other transversal is split into congruent parts. So we know that UZ is the same as ZX is the same as XT, and we know that WY is the same as YX is the same as XV. So I need to find WV. WV is from here all the way down. So I need that entire length. Well, if WY is 2.25, then so is YX, and so is XV. So to find WV, I add those 3 up. So WV is 2.25 plus 2.25 plus 2.25. I'm not the best with decimals, but I believe that is 6.75. And there's the entire length of WV. Again, parallel lines, cutting one transversal into congruent segments, cuts all of the transversals into congruent segments. Okay, number 5 here, it says, what are the values of x and y in the parallelogram? Okay, so we know that this is a parallelogram. So we have the definition, we have 4 properties. Well, I see 2 angles that have y. They are the consecutive angles. We need to remember that consecutive angles of parallelogram are supplementary. Okay, recall that these lines are parallel. Right, it's parallelogram. So these are same side interior angles. They're supplementary. So here's our equation. Y plus 3y equal 180. These 2 angles add up to 180. This is 4y equals 180 and divide by 4. That's y equals 45. So y is 45. So now we have options here. Okay, we could use that same idea again with 3x and then this angle of 3y. Or we could use a second idea, which is what I'm going to do. Opposite angles of a parallelogram are congruent. To set up the equation, 3x equals y. Okay, going across. Well, I know what y is. It's 45. So divide by 3. There's x. And there's the value of y, 45. Okay, problem 6, halfway there. Find the measures of the numbered angles for the parallelogram. Okay, and I see I have angle 1, 2, and 3 left to find. Alright, so let's start with angle 1. Angle 1 is a linear pair with the 85-degree angle. Okay, so we have a linear pair. And we know that linear pairs are supplementary. So the measure of angle 1 plus 85 equals 180. I'll subtract 85 from both sides. The measure of angle 1 is 95 degrees. Okay? And I'll put that on my picture. So that angle 1 is now 95. Now, I'm going to use the triangle angle sum theorem. Angle 1 is 95. We know this 48-degree angle. So angle 2 has to be what we need to make 180. Okay, so the measure of angle 2 plus 48 plus 95 should add up to 180. This is the measure of angle 2 plus 143 equals 180. Subtract 143 from both sides. The measure of angle 2 is 37 degrees. And I'll put that on my picture. And now lastly, how do we find angle 3? Well, we have to use the definition. I'm going to do it right here. The definition of a parallelogram, which says that we have parallel sides. And if lines are parallel, angle 2 and angle 3 are alternate interior angles, and they are congruent. So the measure of angle 3 is exactly what the measure of angle 2 is, which is 37 degrees. And there's the 3 angles in this parallelogram. Okay, question 7 here, sort of like an analyzing question. Can you show or can you prove that this quadrilateral is a parallelogram based on the given information, and explain? So we need to think about the definition of a parallelogram and those 4 properties. And the extra one that says if one pair of opposite sides is both congruent and parallel, then it's a parallelogram. Well, I look at this picture, and the only thing I see that one diagonal is bisected, right? That's what it means with these 2 segments being congruent. I know nothing about the other one, right? This one could be, this one could be 10. I'm sorry, that's bad color. This one right here could be 10, and this could be 4. I don't know anything about them, okay? So I do not know if that other diagonal is bisected. So therefore, I cannot prove. I cannot prove it's a parallelogram. Because both diagonals aren't bisected. Okay? That's the idea. You have to have both diagonals bisected for it to be a parallelogram. I only see one. Alright? So be critical. Be very critical of these pictures. Okay, problem 8 here says, for what values of variables must a, b, c, d be a parallelogram? So I look at this figure and I see two variables, x and y, and I'm saying, okay, I need to work with only the same variable. So I look at the ones that have x, and that's angle A and angle B. And I say, okay, for this to be a parallelogram, A and B are consecutive. Consecutive angles of a parallelogram are supplementary. So angle A and angle B better add up to 360. And that's exactly what I'm going to do. 3x plus 10 plus 8x plus 5. Not 360, I'm sorry, equal 180. Supplementary, equal 180. Okay, so 3x and 8x is 11x. 10 and 5 is 15. Subtract 15 from both sides. 11x is 165 and divide by 11. X is 15. And there's my value of x. So now I'm going to do the same thing, okay, with this pair of consecutive angles, A and D. So I'm going to use the same idea. 5y plus 3x plus 10 equals 180. Except now I have what x is, so plug it in. 5y plus 3 times 15 plus 10 is 180. 5y plus 45 plus 10 is 180. 5y plus 55, 45 and 10 is 55, is 180. Scroll down a little bit. Subtract 55 from both sides. 5y is 125 and divide by 5. And I get a y value of 25. And there's the values of x and y that make these consecutive angles supplementary, which makes this quadrilateral a parallelogram. Okay, next problem here, number 9. We have a rhombus this time, okay? So we need to figure out what are the measures of these angles in the rhombus. All right. Well, a couple ideas here. I'm actually going to start with angle 2. I know that the diagonals of a rhombus are perpendicular. So where they meet are right angles. So I know that the measure of angle 2 is 90 degrees. There's one. Okay. So maybe I'll put that on my picture. And I should know that all of these are right angles, right? All of them. Okay. Now I'll go with angle 1. I also know that the diagonals of a rhombus bisect opposite angles. So I know here in this picture that angle 1 and 60 degrees are the same, are congruent. The measure of angle 1 is 60 degrees. Now I also know that these 60-degree angles are also here and here. I know that as well. So I know that this angle is 60 degrees. And the reason I'm placing that angle there is because I need to find angle 3. And angle 3 now is in this triangle with a 60-degree angle, a 90-degree angle. I can use now the triangle angle sum theorem, which says that the measure of angle 3 plus the 60 plus the 90 better add up to 180. 60 and 90 is 150. Subtract 150 from both sides. The measure of angle 3 is 30. And there are the 3 angle measures in this rhombus. Okay, let's take a look at this picture, this problem. Sorry. ABCD is a rectangle. Find the length of each diagonal. Okay, so a lot of your problems on your quiz are not going to have pictures, so you need to be able to draw. Well, this is a rectangle. It's a rectangle. One angle is a right angle. They're all right angles. A, B, C, D. Draw your diagonals. So AC is this one. BD is that one. What do we know about diagonals? We know that the diagonals of a rectangle are congruent. So I know that 2 times 5a plus 1 is equal to 2 times a plus 1. So first thing we do is we distribute. Right? We're looking for the length of each diagonal. So we distribute both sides. 10a plus 2 equals 2a plus 2. So then, we're going to subtract 2 from both sides. The 2's cancel here, and the 2's cancel here. Uh-oh. This is kind of a weird problem. Well, let's keep going. Now combine your a's, right? This is 8a equals, uh-oh, that's 0. It's okay. Keep solving. Divide by 8. 0 divided by 8 is 0. The a value is 0. Who cares? It's 0. Plug it in and see what you get. So if we come over here and plug it in, AC is 2 times 5 times 0 plus 1. 5 times 0 is 0, so it's just 2 times 1. AC is 2. Do the same thing for BD. BD is 2 times 0 plus 1. The 0 goes away, that's just 1. 2 times 1 is 2. And it works out, because the diagonals must be congruent, so here we go. They are. Alright? So a little bit tricky algebra, but no big deal. Diagonals are congruent, life's good. Okay, 2 more problems here. This one is another analyzing one. Can you conclude that the parallelogram is a rhombus, a rectangle, or a square? And explain. Okay, so I'm going to write down rhombus, rectangle, and square. So the first thing I recognize is there are no right angles. No right angles. There's nothing that tells me there is. So it's not a rectangle, it's not a square. So could it be a rhombus? Well, look what the picture shows. The picture shows diagonal bisecting opposite angles. Isn't that a property of a rhombus, that the diagonals bisect opposite angles? Now look over here. What if we draw on the other diagonal? Okay? We draw on the other diagonal. Now we know that this is the parallelogram. So we know that the diagonals bisect each other. So I know that this is congruent to that. I know this side is congruent to itself. And I know that these... Oh, this is a parallelogram. So I know that this side is congruent to itself. I know that these two sides are congruent because the diagonals bisect each other. And the tricky step here, look at this big triangle at the top. These two angles are congruent right here. This one and this one. So by the converse, I'm going to write that right here. Converse to, this is the tricky one. Isosceles triangle theorem. This side is congruent to this side. That's the tricky step. So these two triangles are congruent by side, side, side. And now, if we look at the corresponding parts, this part right here is congruent to that part right there. They're the corresponding parts. And that means that this diagonal bisects that opposite angle. Now we have both diagonals bisecting opposite angles. This is a rhombus. Rhombus because diagonals bisect opposite angles. Okay? So there we go. So a little tricky there, that picture. But really think hard, think analytically about those kind of problems. Okay, last problem here, problem 12. It says, for what value of x is the figure going to be a rhombus in this case? Okay? So I look at those angles and I say, okay, they're part of a triangle. They're part of this triangle right here. I'll use blue. So can I do something with that triangle? Well, what do we know about a rhombus and the diagonals? We know the diags of a rhombus are perpendicular. So what that means is that this is a right angle. And now I know this angle these two angles have x in them, I can use the triangle angle sum theorem to solve this problem. I'm going to add those 3 angles up. They will give me 180. That is 11x plus 103 equals 180. Subtract 103 from both sides. 11x equals 77. Let me scroll down just a bit. Divide by 11. And x is 7. And that is the value of x that will make this situation a rhombus. Okay. So I cannot stress enough, know your properties, know your note cards, know your stuff before you walk in class, take that quiz. All right, have a great weekend. We'll see you on Tuesday or Wednesday.